Welcome to my screencast on the wheel and axle. Let's start with this.
Are you stuck in the bathroom again? Dear Tim and Moby, can you tell me about the wheel? From Valerie. The wheel is another device that falls under the category of simple machine. But we can't really talk about wheels without also talking about axles. For a wheel to do any good, it has to rotate on a rod called an axle. Like I said, the wheel and axle is a simple machine, like the lever, inclined plane, and pulley. Simple machines are the most basic tools out there. They allow us to move things more easily by magnifying our efforts. The wheel and axle is actually a rotating lever that moves in a circular motion around a fulcrum. I think somebody needs to watch the Levers movie. Okay, take this doorknob. It's a wheel and axle at work. The knob is our wheel, and this metal rod is the axle. And they turn around this point, which is called the fulcrum. Without a knob, it's pretty hard to turn the rod. It takes a lot more effort. The big knob magnifies the force of the turning motion. The wheel movement is turned into a shorter but more powerful force at the axle. You have to turn the outside of the wheel farther than you want the axle to turn, but that extra distance is translated into more turning power. It's a trade-off. Hey, good job, Moby. You've shown us that the wheel is just like a round lever. Is that my toothbrush?
All right, let's talk more about the wheel and axle then. As you saw from the clip, there are many examples of a wheel and axle. One is the doorknob. This is the biggest wheel and axle in the world, and it's called the Singapore Flyer. It's like a Ferris wheel. And we want to focus in today on learning more about how wheel and axles might magnify force or speed. For all you people out there, there's also a similar one to this in London. So what makes a wheel and axle a wheel and axle? Well, first of all, it's important to note that the wheel must be fixed to the smaller axle. So when they rotate this way, both the big wheel and the axle rotate in the same direction. So they're fixed. It's almost like they're cemented here or welded. And unlike gears, one rotation of the wheel will equal one rotation of the axle because they're fixed. If they weren't fixed, basically all you'd have is something like a pulley system. So let's look at some everyday examples. Big helicopter blade. So you spin this, which then spins the big wheel, which is the helicopter blades. If we turn a screwdriver, the bigger handle spins this smaller thing and taps on faucets, steering wheels on vehicles are other examples of wheel and axles. As you heard in the Brain Pop clip, the wheel and axle is simply just a lever that rotates in a circle around a center point, and the center point would be the fulcrum. The effort force is usually applied to the big wheel, and the axle spins with it. However, that's not always the case, and so let's learn about how we might gain an advantage from using the wheel and axle. So here's another picture. We can get a mechanical advantage, which means we amplify our force, if our effort is put on the wheel and the load, whatever that might be, is hooked onto the axle. And we have another formula that we can use to calculate this. If we knew the radius of the wheel and we knew the radius of the axle, we can calculate the MA of a wheel and axle by dividing the two. So radius wheel, W for wheel, divided by radius A for axle. So in this case, 5 inches versus 1. So 5 divided by 1 gives us the MA of a 5. So if I applied a force here on the wheel of 1 Newton, I could amplify my force and lift something that was 5 newtons. Here's another example. So how much effort would we need in this particular picture of a wheel and axle if the load or the output was 5 newtons? Well, let's look. We know now that our MA of a wheel and axle is to take the radius, or it could be the diameter, of the wheel divided by the radius or diameter of the axle. Another way to say that is take the radius of your effort, which is usually on the wheel, divided by the radius of where the resistance is, which in this case is on the axle. So let's go to our picture. Here's the load. It's 5 newtons. So MA would equal, the radius of the wheel is 12, so let's put 12 on the top according to our formula, divided by the radius of the axle, which is 2, and we find out that the MA is 6. So that means whatever my force is on the wheel, I can lift 6 times as much on the axle. Okay, well, if the load was 5, how much would we put in here? Well, let's use our formula. We know the MA now, and in general, any simple machine, it's output force divided by input. So 6 is the MA, that goes here, equals the output is the load or resistance, that's 5 newtons, divided by whatever our input force is, which we don't know. So 5 divided by what equals 6. Let's get out our trusty calculator. And let's go 5 divided by 6 equals 0.83. Let's go back to our PowerPoint. So it would be 0.83 for input force. Get my pen back going. 0.83. Okay, but what if we switch the resistance or the load and your effort around? So now let's put the load on the big part, and let's put the effort on the smaller rotating piece. Well, now it's a different situation. So here's our MA again. Radius of wherever you put your effort, which in the last case it was on the wheel, but this time it's on the axle, divided by the radius of wherever you put your resistance, which now is on the wheel. So let's say we knew the diameter here, which is where we're putting our the radius here, and we knew the radius here. Let's say this is 6 and this is 2. Let's use easier numbers. This is 5 and this is 2.5. Okay. So radius of where our effort is. Okay, that's on the little axle. So that's 2.5 divided by the radius of our resistance, which is on the wheel now, and that's 5, and that'll give us the MA. And the MA is 0.5, which means I've got to put twice as much effort as my load. So if my load is 5 newtons, I've got to put in 10 newtons of force to lift it when I move these things around. Now, you're thinking, well, what's the big deal? Well, watch, when I pull down now on the axle, the load is going to come up twice as far, and that's the big deal. That's why we might want to switch these around. We have to put more effort in, but it goes a further distance. So when this happens, when we do have this situation, we get what's called a speed advantage. It takes lots of force, but this load's going to go faster, farther. Here's one more picture. So when we use a well, we might hook the load or the resistance up to the axle, and we might put our effort force on the big wheel, and in this case it's going to be really easy to lift the bucket. The bigger we make this wheel, so if we extend this even bigger, it's going to make our effort even easier, because remember, the MA is always equal to the radius or diameter of where you put your effort divided by the radius or diameter of where you put the load. So if this is really big and the axle's really small, you're going to get a big MA. And that's my quick explanation of how wheel and axle works.